We're going to talk about another concept with respect to the thermodynamics of steam called superheat. And what I'd like you to do for a moment is just consider a conveyor belt. And let's say maybe the conveyor belt is moving a product like gravel. Now, the conveyor belt moves at a given speed. And we can move more or less product simply by adding more gravel to the conveyor belt at one end, or not adding as much. So the amount of product that the conveyor belt is actually moving is quite variable. And if we use that analogy with steam, steam at a saturation temperature has a given heat content, and it will actually, like the conveyor belt, it will actually carry that heat content, or that product which is heat energy, to another location, such as a heat exchanger or a turbine or some similar type of power plant equipment. What we can do though is, if we, just like we want to add, move more gravel on the conveyor belt system in a shorter period of time, we can actually add more heat content into the steam after it's actually reached its saturation temperature and absorbed all its sensible and latent heat and made that phase change from water to steam. So basically what I've done here is I'm boiling some water, and that water is going up through this little coil, which was intended to sort of simulate a superheater in a steam generating unit. And what I'm going to do is I'm going to add a little bit of extra heat, hopefully with the use of the propane torch, through the superheater, or my little pseudo superheater coil, into the steam that's actually coming out the discharge. Now, this is boiling, and it is actually at 100 degrees Celsius because we're not allowing the pressure in this container to get much higher than atmospheric pressure. It is vented, so it's the thermometer is actually in the steam space, and it's measuring the steam at 100 degrees Celsius. So what I'm going to do is I'm going to light my torch. And what you're seeing is some steam escaping out of the open end of my little superheater coil. You can actually see it. And basically what's happening is it's still right at the point of saturation temperature, which is 100 degrees Celsius. And as soon as it hits the atmosphere, it generally tends to lose enough heat that we can actually see it. It's being absorbed into the air, and it's very, very close to its saturation temperature. What you're going to find is as the coil heats up, the steam that's going through it is going to start to pick up more and more heat all the time. And you're going to start to see this visible wisp of saturated steam disappear. So you can see that the visible portion of the steam, the saturated steam, is virtually disappeared now. Now we're still boiling water, and it is still coming through the coil, but it's picking up a lot of heat, and its temperature has actually gone way above 100 degrees Celsius, which is its saturation temperature. And right now what we're doing essentially is we're adding a lot more heat energy into the steam, and it becomes a bit more of an efficient process in terms of moving heat energy to our power plant equipment. And in fact, just to sort of show you how hot it can actually get, how much heat energy it can contain, it does actually get hot enough to light the match. So there we're starting to see the odd wisp of steam come out of the end of my little superheater tube. And as time goes on and it carries away the heat in the coil of copper, then it'll show more and more and more steam. Now it's returning back very, very close to its saturation temperature, and that allows us to see it when it hits the atmosphere. So there's our little demonstration on the concept of superheat.